Well, good morning. Thank you, everybody, for coming, and thank you for spending the time last night. That was a lot of fun. So now we'll get into the lectures, and as tradition, I'll start, and we'll talk about the kidney and complement. And I have three goals in this lecture: to understand renal anatomy and how C3G is diagnosed, to understand the complement cascade and how it normally functions, and to understand the four pillars of a complement evaluation. Some of the slides will have a red star. Those are the only slides you need to remember. And associated with those slides, there will be a question to Brian and to Tucker alternating. So please pay attention. Just kidding. Just wanted to see if you were paying attention. So each of us has two kidneys, or most of us do. Some of us only have one. And your kidney is about as big as a cell phone. It weighs about half as much as a can of Coke. In your body, you have about 1.5 gallons of blood. And that blood is circulated and filtered by your kidneys 20 to 25 times a day. So that's huge. In your kidneys, there are filtering units, and those filtering units are called nephrons. And each kidney has about 1 million nephrons, and there's a range. So all of us with two kidneys have about 2 million nephrons doing the filtering. Your kidneys control your blood pressure. They make EPO, which is essential for your red blood cells. So some of you, when you were on dialysis, had to have EPO shots. They convert vitamin D to its active form, and they control the pH in your blood. So they are super organisms. So getting a kidney biopsy, all of you with C3G have had to have a kidney biopsy. You'll notice that the right kidney is lower than the left kidney, and that's because the liver pushes the right kidney down. When you get a biopsy, we are looking at the glomeruli in the nephron. The glomeruli are in the renal cortex, and so the kidney is divided into the cortex and the medulla. The biopsy is done under guidance, under ultrasound guidance. And the result is a needle that passes through the capsule of the kidney, and then the cortex, and then the medulla. And because the needle is hollow, when it's withdrawn within the needle, there's a core of tissue. And that core of tissue is about 1 millimeter wide and about 20 millimeters long. It's kind of like a little bit of lead from a pencil. And in the cortex, you can see the red dots. And those red dots represent the glomeruli, and this is in the medulla. So this is the first important slide, Brian. And when they do the biopsy and when they read the biopsy, they do light microscopy, immunofluorescence or IF, and electron microscopy or EM. And to make the diagnosis of C3G, they have to do the important 2 points here are the IF and the EM. So when Carla and I read biopsies that you've had, we look at the IF and we want to know how dominant the C3 staining is, which is shown, which is shown here. And typically it has to be 2 orders of magnitude greater than any other immunoreactant. And then we look at the EM to see whether there are deposits like this, which would make us call a diagnosis of dense deposit disease, or they're fluffier and lighter like this, which is consistent with C3GN. Now, interestingly, in France, they don't routinely do EM. So there's That's just the way they do it. They just don't routinely do EM. But when you get your biopsy and you talk to your doctor about your biopsy, you want to ask them about the IF and the EM. So when the biopsy is read, if there's a lot of C3, it'll be called C3 dominant glomerulopathy. It won't necessarily be called C3G. There's a dominant word here. And that's because in the differential diagnosis, we also think of post-infectious glomerulonephritis and MGERS, monoclonal gammopathy of renal significance. So C3G and post-infectious and monoclonal gammopathy of renal significance all look the same on biopsy. The biopsy is a descriptive biopsy. It doesn't tell you what is causing the problem, but it tells the nephrologist what line of investigation to follow. So let's now move to the complement cascade. The complement cascade in all of us provides the first line of defense against infection. It marks as dead foreign cells so they can be removed. What movie is that from, Brian? Yes, Monty Python. It talks to other systems in your body, so the response is coordinated, and it's on all the time. That on all the time is called tickover, so that's what complementologists call it. That was discovered by this gentleman, Peter Lackman, who was a well-known complementologist. He died a few years ago. He was knighted for this work, so Sir Peter Lackman discovered tickover in the 1960s. And so the complement cascade has to be tightly regulated. It has to be balanced. The disease is a question of balance. Too much control and too much regulation can lead to disease, and too much activation can also lead to disease. So the three phases of complement activity are the initiation phase, the amplification phase, and the terminal phase. So this is another thing to remember. Complement has three phases. This shows the initiation phase, the amplification, and the terminal phase. So relevant to us, relevant to C3G, is the alternative pathway. So in the complement system, the only thing you need to remember is the alternative pathway. The alternative pathway is the initiation phase. There's an amplification loop with C3 convertase. So you need to remember the amplification loop. And then there's the terminal pathway. So how do we evaluate the complement system? In every one of you, when samples come to the lab, we do four things. So remember, an adequate complement evaluation has four pillars. All of you have had a genetic analysis. In all of you, we look for autoantibodies. In all of you, we do functional assays. And in all of you, we do biomarker levels. If you don't do all four, you're not doing an adequate, thorough complement evaluation.